let's go through and plot these numbers on a number line. We're going to construct it ourselves, and the best advice that I can give you is find your minimal number. This is going to be our smallest one, and then find your largest number, and that's going to be 2 pi. 2 pi is going to be about 6.28, and so that says that, you know, our number line has to be greater than 6, or at least show 6, so we can go a little bit past it. And then our minimal value is negative 1.2. We need to have at least negative 1 with enough room to show where negative 1.2 would be. Personally, I'd recommend showing at least negative 2 on. So your number line should look something like this. Pause the video if you're doing this at home and use a straight edge, or at least go as straight as you can. Neatness really counts here. And then we're going to take time to actually go through and place these numbers on the number line. Negative 9, I know it's got 2 answers, but we're just going to stick with the positive one. So that's going to go at positive 3. So we're going to make sure that we draw a line from negative 9 straight to positive 3, so there's no mistake about where that goes on the number line. You don't want to just have it sitting right over there, and in case your sloppiness, if it's a little bit to the right or left like this. Well, does that look like it's at 2.9? It's a judgment call that you don't want to leave for the person that's taking a look at your work. You want to communicate very clearly where you want that to go on the line. Next, we'll take a look at negative 1.2. Well, that's not the hardest thing to take a look at, because really we could look at that in decimals, or we could also look at it as negative 1 and 1/5. And I'm more of a decimal person myself, so let's go ahead and move that to the proper spot. Let me get that stray mark off the side there. Now, here's 0. There's negative 1. So here'd be negative 1.1, and negative 1.2 would probably be about right there. So we'll kind of move that over, and then we'll draw the line exactly where we want it to go. There we go. That's pretty good. It's not exact, but we know it's definitely not negative 1.5. It's definitely closer to the negative 1 than it is the negative 2, and that'll serve our purpose there. When we take a look at any fractions, this is where you want to be very careful. And in fact, I'm going to take this and zoom in on a number line on the next screen so we can spend a little bit more time looking at it. Sometimes I find it helpful to think of fractions as just counting, and you look at that bottom number and you go, okay, between the two integers, or any two integers, I'm going to divide it up into however many parts that bottom number is. If this is a 5, I'm going to divide it up into 5 parts. And you know, this would be like it's 0/5, then it would be 1/5, 2/5, 3/5, 4/5. 1 is the same as 5/5, right? 5 over 5 is the same thing as 1. And then this would be 6/5. So I could place it right here at 6/5. Another way to look at it is 6/5 is the same thing as 1 and 1/5. So you could instantly go to 1 and then just basically space it out in fifths between 1 and positive 2 and go, okay, here's the next one. And so you could say this is 1 and 1/5. But if they give you a specific number, make sure that you rewrite it. Like, here we go, this is 6/5 right here, and I'm showing that the 6/5 goes right here. Rather than drawing arrows and everything else and making it really sloppy, just write it above your number line, 6/5, and make sure that you just point downward. Now, I want you to remember how we turned 6/5 into a mixed number, and that it was 1 and 1/5, because we're going to go back to the next previous screen and actually go and fit 6/5 into, let's see, there's probably 1/5, 2/5, 3/5, 4/5, 5/5. We know that 6/5 goes right here. I'm going to just draw a line straight down there, so that way everybody knows exactly where that one goes. There's nothing wrong with leaving these little tick marks here, because that's actually showing how you were planning it out and where the 6/5 went. If you wanted to erase them, that's fine, but personally I would say you'd be better off just leaving them because it's just a little bit more of a mental breadcrumb trail showing the person how you figured out where the 6/5 went. Now, let's take a look at 0.1 repeating. That's the same as 1/9. And I mean, if we wanted to go through and break this down into 9 different parts, we can, but you tell me. I mean, shouldn't it be like pretty close to 0 right there? I think everybody's okay if we just basically just slid this in and showed that 1/9 is about right there. And now we've only got 2 left. We're going to have to kind of approximate both of them because they're both irrational. All of these are rational numbers because we could turn each one of these into a fraction. These two were not able to. So the square root of 5 is right about here. We would estimate this to be roughly 2.2, maybe 2.3, but I'd say probably 2.2 if we're going to the nearest tenth. And so that's set up in a proper spot. And now this is the same as 2 times pi. We already took a look at the fact that that would be the same thing as pretty much 6.28. So if here was 7, if that was 7, 6.28 would probably be right about here. So let's go ahead and move 2 pi over here and then just draw a line and put it right there. It takes a little bit of work, especially if you're a little uneasy working with fractions or imperfect square roots, but the more that you work with this type of activity, the easier it gets, and that's what we need to do is just practice, practice, practice.